Hello, everybody. In this video, we are going to talk about certain aspects of kinematics. Kinematics in physics involves the study of motions of objects. Right? So when we study the motion of objects, we will try to explain, we'll give a description, or we will express it with values. So many meters per second, or meters per second, by using different units, or we might draw a graph, sometimes maybe just an image. So there are certain terms you need to know. They are distance, displacement, speed, velocity, acceleration. Once you know what these terms are properly, it will be easier for you to apply that knowledge to learn further on kinematics. Okay. So before I talk about these terms, let me tell you what is a scalar in two new terms and vector. So now if you read my book on physics, you will learn these things, but here's a mini video. So I will cover certain aspects of the year and then other aspects. All right, scalar, these are quantities that are described only by a magnitude, which means a numerical value. Okay, so it is described only by a value, numerical value. Okay, so we say magnitude. When it comes to vector, it has a value, just a magnitude is there. Tells the quantity, it's expressed with the magnitude, and also it has a direction. So if we take anything, any value, or any of these terms, let us take distance for an example. Okay. Now, if you say the distance, just take out, we say 10 meters. Now we know about SI units now. US customer, if it comes, we'll use it. You need to be able to convert. We know all that, assuming that you know, you watch my videos or some other video. So distance, we say 10 meters. It doesn't tell you whether it is going up or down or right or left or any other direction. Just tell a value. That's a magnitude. So this is a scale. Okay. So there is no direction. Therefore, it becomes a scale. Now, when it comes to displacement, it has a direction, a set direction. So if I tell somebody is running in a circle and starting point is A, goes around and come back to A, the person has run a distance. Each point the direction changes, right? It changes. But if we ask the displacement here, start from A and come back to A. There is no displacement, it's 0. Okay, because displacement is a vector, because it has a direction and a magnitude. It tells you displacement happens positive, negative, left or right, up or down. Okay, so you can take a graph and draw and say if it moves to right, it's positive. If you move to your right, and if it moves to your left, it's negative. Up, it is positive. Down, it's negative. You can have that. Okay, you can have these standards if you have to compare two directions. So you have to set up that properly. Okay, we can stick to that. But if you're talking about just one direction, we say something falling down, you can just take it as positive and just do the calculations. Okay? But if you have something going up and coming down, then you have to treat it like positive and negative coming down. Okay? So those the direction given by positive or negative, or even you can say east, west, north, any direction, those are vectors. So displacement is a vector. So if somebody tells the direction with went on 30 meters per second to the east, okay, quickly becomes a vector. Just tell the direction. So not just a magnitude direction. Okay. Now, if somebody tells about, for an example, if it is a temperature or something, that's just a magnitude. Okay. They are scalars. If you have a computer, the measuring quantity, we say 250 bytes, that means it is a scalar. Calories, or those things. But if some magnitude or the value is attached to a direction, then we call it a vector. All right? So let us take now the circle, we'll take the square. Let's say a square. Okay. Rectangle. So we say 5, 5, 5, 5. Now person starts here, goes to the left 5. We say left is -5. Coming down we'll say -5. Then going this way, we say +5. And then going up again 5 is plus. So his displacement, this man's displacement is going to be 0. Okay. This could also say, instead of going to left, right, you can say going to the west, going south, going east, east here. This is west, just different terms, south, and then north. When you calculate all those things by putting the right sign, negative or positive, you get 0. But if I ask okay, write the whole thing, otherwise it looks like this distance, displacement. Okay, so distance, get stuck under here. Distance is 5, 5, 5, 5, 20 meters. Okay. All right. I hope you understand what I mean by displacement and distance. Now let us go for speed and velocity. Speed is given by distance divided by the time. Okay, because per is the rate. How many? So the rate is relevant to the distance here. So within a given time period, it could be per second, per minute, per hour. Okay, we go for per second because SI units. What distance something has traveled, an object, a man, or anything has traveled. Speed. But because distance is a scalar, it didn't give any. It didn't give any direction. The speed is a scalar as well. Now, if I take velocity, I take the displacement divided by time, then it becomes a vector. Okay. Now, what are the units? So if it is speed is, just put speed S here. So this is distance divided by time. So distance would be given in meters, time is in seconds, it's meters per second. Right? So velocity for v, then displacement by time, it's also meters per second. But the difference is this displacement here is the net value of the magnitude, net value. When I mean by net value is it has gone up or down, then it cancels out. If I've gone west or east or left and right, it's got cancelled out. Okay, so whenever the value you get it will tell you, so meters per second, and then it will tell you the direction. Okay. Maybe east, they might say, or west. Remember, if it is given up or down or some other way, or to the left or the right, the direction should be there. Then it's the velocity. Okay. Now, when we take about it, I just want to tell you this. So there's something called average. Average velocity. Whenever you have average, it means you have the initial and beginning, and you divide it by time. So you have a so average velocity, we'll say, it's given by velocity final minus velocity initial. How do you get velocity? Displacement by time. Divide by 2, you get the average velocity. Remember that. So if you get in the speed, it's also same. Sorry, we add those values together, and then you divide by that. That's the average velocity or average speed is given by that, because initial, final, and initial, or initial and final, but you add them together and divide by 2. So that's a way of getting the average velocity in this case. Another way of telling is average velocities, you get the initial, final, or you can get the total velocity divided by total time, right? Because to get the average, you have to get the entire distance. Sorry, not the total velocity, entire distance. Total displacement. Okay. So that's the total time. So remember, average is you can get the initial and the final positions, and then get the total and velocities, and then divide by 2, or get the total displacement divided by total time. Then you get the average. Okay. All right. Now, when they're telling somebody's going, I'm using the discuss 30 miles per hour, and then you are stopped by traffic police. What it means is, at that moment, that instant point, your speed was 30 miles per hour. Okay. But if you tell the policeman to check the average means the time you started, initial, go all the way to the final, or at least the point you are stopped. You take how long it took and the total distance, then you get the average. speed here, because when you're going on the road, it's not a straight road, it's not like that. So speed, the average speed is that. Average speed would be 30 miles per hour. So that is the instantaneous. That point is what we're talking about, okay? So to make it further explain, so let us say average. I gave you an equation first to find the average velocity. You add the initial and final together and then divide by. You can do that. But otherwise, average speed is given as distance traveled, the distance traveled, divide by the time of entire travel. Right? It is not going to be. So when you're stopped, you can talk your way out of telling it's the average speed was not even near to 30 miles per hour or something. Try that. Okay, so it's better to accept it if you have been speeding anyway and not to speed anyway. It's a privilege to be able to handle the car and then go from A to B. All right, so average velocity, I told you before how to get average velocity. You have the displacement. I put delta here because this Greek capital letter delta means final minus initial. So it shows a displacement. That means it will have a direction. So you divide it by time, but I can say delta position. Okay, so when I say position, so if this is time, I'm drawing a graph now. This is 5, 10, say 20, just 20. So if you went with time, going like that, went 20 meters, you came back 10. The actual distance you have traveled is from 5 to 10, that's 5, right? So it's 5. So that's the delta value, means the difference. It doesn't matter how far you went and coming. Final, initial, final 10, initial, final minus initial, that's the delta value, that's the change. In chemistry, you use small delta here to say the small charge, partial charge. But here we use final, F means final, initial, the difference. Here the final is 10. You went 20 and came back to 10, right? So n minus 5, we traveled only 5. That's all. Now let's take an example. So at the end of this mini lesson, you have studied the speed and the velocity. Okay, we'll do the acceleration and in a bit. So example, we'll say somebody traveling 600 miles. I'm using US custom because that's what you come across now. We'll say we traveled the whole thing in 6 hours. Okay. Now, we are looking for the average speed. That you must know. Average speed, because it doesn't tell any direction. It's just mile. So average speed is going to be distance, total distance. So this is the total distance, not the displacement. Divide by 6. So you have 100 miles per hour. Okay, that's the average. But this is the average. So if you're going from A to B, that was 600. Must have gone 600, then 100, 50, and just slowly, and then speed up. But whatever increase the speed or level, the total average is 100 miles per hour. That doesn't mean all the time 100. Maybe 200, then the next time it was 5 miles per hour or whatever. When you add them, so average you get it by this way. All right. Now, what is instantaneous speed and average speed, which I told you, 30 miles per hour at that point, the point at which, so if you're just going a distance, I'm just trying to say position here, meters we'll say, time in seconds. So if you're going like that, from here to here, the time, the total distance from here to here, you get right. That's the total distance. Total distance is the total time. Then you get dt over dt as total. You get the average speed. But if you want to find this point, okay, you can draw a line, a tangent to that, and get the slope. Get the slope of that point. Okay, that is called instantaneous. Instantaneous speed. That's where you get caught if your speed. Okay, that's for this. Average speed is distance time ratio, right? Now let us talk about acceleration, and then we'll stop this video. The next time we'll come to graphs. Okay, so when it comes to an acceleration, it means velocity, which is a vector, divide by time, you get another vector. Okay, so velocity is given by meters per second, and then second here. So you get meters per square second squared, or per second twice. Okay, so sometimes they might put it like that. Same thing. So that is the acceleration. So acceleration actually means the rate at which the velocity change, right? The rate at which the displacement change was the velocity. Rate at which the velocity change is the acceleration. Now, when you do the graphs, you will remember, you will get a better understanding and remember it better. So if there's a constant velocity, and I do the diagrams here, so make sure to check the next video. Constant velocity and constant acceleration. Now, constant velocity means if the change, that position to time is same always, it's a constant velocity. Okay, change in the position to change is same. Then it's a constant. So change the position is changing exactly the same time means constant velocity. Similar to that, constant acceleration means velocity, the change of velocity is the same. That's change of velocity. When I say delta V, that means final velocity minus initial velocity divided by the time. That change is constant. So you get a constant acceleration. So just remember that. If the velocity change is the same per time, then it's a constant acceleration. If the change of position, the displacement is same per time, then it's constant velocity. All right, so just think about these things, and then you just use what we have given here. So next time I will talk to you about the diagrams, and then we'll bring in free falling objects. What happens? Free fall. When something falls, it's the gravity that is acting upon it. But I want you to know about the ratio from why different weights would fall the same time, and what is the ratio between that, then bringing the weight, mass, and weight into it. All right, everybody, I hope you enjoyed this video.